Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more. Help us to share our video and also subscribe to our channel. Help us to share and also subscribe if you have not subscribed before. Just press on the subscribe button. At this moment, we have over 200 videos on our platform. It means you can come to this place and learn any topic of your choice: mathematics, physics, and chemistry. We have more of mathematics, few of not much of physics, also quite few of chemistry. But as time goes on, it will be fine. Once again, Further Solutions Academy. If you want to contribute, we need many things at this moment: bigger board, better camera, also to buy things like even the marker I'm using now. You can reach us on this number. With this number, with this phone number, you can call us, you can WhatsApp us, and also Telegram is allowed. Telegram is allowed. Please, we need your help. No amount is small. Now, I want to work on this part of physics, which is called elastic property of solid. Elastic property of solid. Elastic property of physics. Of solid. It's a nice part of physics that is good to understand this part so that it can be verified. Okay, when we talk about elastic property of solid, number one, something that will come to our mind is Hooke's law. Hooke's law is very, very important at this point. Now, let me quickly state Hooke's law. Hooke's law states that the change in length, or extension E1 of an elastic body is directly proportional to the applied force or load F, provided that elastic limit of the body is not exceeded. Okay, that is Hooke's law. That is what Hooke's law is talking about. It means what we are trying to say here is that we are saying that our force is directly proportional to what? To E. Now, it means normally this is variation in mathematics. Now, I can say that my F is equals to KE. Why my K is what? Is constant. Is constant. My K is known as constant. Now, constant force, which is constant force is very important, which we know what force is and inverse of that. Now, it means my F, which is my F, is equals to what? Mg. My F is equals to mg, which is, we are talking about mass multiplied by gravity, which is the acceleration due to gravity. Anyway, acceleration due to gravity. And also, we know that my E is equals to extension or compress. Now, extension or compress or compression of the body. Now, and okay, of the body or material anyway, it's good to use elastic. You can also call it elastic material. Okay, now with what is on ground, you can see what Hooke's law is talking about. Now, okay, before we move on, we have to understand what is called a Young modulus. A very good part of physics that everybody must understand under this topic. Young modulus. Okay. Now, when we talk about Young modulus, I have what is called Young modulus here. Young modulus. Now, Young modulus which is, we always like it this way, is defined as the ratio of tension. At the rate of tension stress to okay, that is what our Young modulus is talking about. It means what I'm saying there is that I'm talking about what? Tension stress divided by okay. Now, let me define this one by one. Okay, we have this, which is the ratio of the extension of a material to the original length, which is I have my strings equals to change in length divided by original length, which also can be equals to extension / compression divided by original length. Okay. Now, which I'm talking about what? E all over L. E all over L. Now, with this, you can now move on with, before we talk about it, let me try to relate it to force. Now, let me try to relate Young modulus to force, because all these force are involved. Now, when we talk about force, it means my equals to force divided by area, which I'm talking about F all over E. We all know what my F is, which also will be my F all over pi square. Now, okay. Now, with this, I cannot say your modulus, which is can be equals to divided by, which is what is my base is force all over area divided by, which this one will be what, E all over, which also the same thing as force divided by E divided by E all over L, which also the same thing as what, force multiplied by L divided by A, which is also the same thing as force L divided by AE. Anyhow you call it. Anyhow. Now, with this, we are good to go. The SI unit, for modulus, Young modulus, is Newton per meter square. Newton per meter square. Please take note of that. It means your SI unit for that is Newton per meter square. Now, with this, we can now try to touch one or two questions or problem on this Young modulus, which is elastic property of solid. Now, time. Now, the first question I would like to touch is, okay, let me quickly look for this question. Let me go with this question. Okay, let me quickly explain work done in, okay, let me explain work done, in terms of work done. Work done in, okay, and elastic. Okay, one guy in elastic. Now, when we talk about work done, we know what work done is all about. My work done is always equals to. Now, in terms of elastic, I'll be talking about when compression, when compressed extended by a force, the energy stored in a pin or pin is also given by equals to 1 over 2 Fe or 1 over 2 Ke squared, which we're just talking about. Now, the SI unit is in joule. The unit of work done, work or energy is joule. Joules. Okay, now let me, with this, I think I've explained in terms of work done and energy. Now, let's move on to one or two problems under this part that can really help us to understand Young modulus, which is elasticity of what? Okay, now I have this question to explain, to solve. An object weighting 0.6 Newton is hung on a steerer spring and cause it to extend 6.0 centimeter. The object is removed. And a block of work replacing it causes the spring to extend by 10.0 centimeter. What is the width of the block of wood? That is the question. Now I have this question to solve, which is very, very simple. You can see an object of this, weighting this, is hung on what? On a spiral spring, and cause it to extend this, which is 6.0 centimeter. The object is removed and a block of what? Of work replacing it causes the spring to extend by 10 centimeter. What is the weight of the block of the wood? Now, if I have this type of problem, how can I go? What should I do? The first thing is, I will first look for what? Normally, apply force, which is F, it will be equals to 0.6 Newton. 0.60 Newton. Now, when we talk about extension, which is E1, it will be what? 6.0 centimeter. Now, which I will convert this to centimeter to what? To meter, because we talk about Newton, it must be in meter, which it will be 0.06 meter. 100 centimeter make 1 meter. Don't forget that. Just using that logic. Since I know that, I will now continue by saying my force, which is constant, K equals to what? F all over E, which we have done that earlier. It means I can say that, which also implies 0.6 divided by 0.06. 0.6 divided by what? 0.06. Now, which I will have it as which I'll be having it to be 10 Newton meters squared. 10 Newton meters. Now, since I have it that way, it means my E equals to 10.0 centimeter, which also to be what? Is 0.1 meter. Now, this is centimeter, this is meter. It means my K, which is my constant force, it will be equals to 10 newtons meter per meter. Now, since I have that, I can have my weight of the wood equals to KE, which is I have 10 multiplied by 0.01. 0.1, sorry, 0.1, which I'll be having 0.1, which 0.1 times 10, which is I'll be having 1.0 Newton. Hope you know this will give us 10 multiplied by 1 all over 10, which is equals to 1.0 Newton. That is my answer, 1.0 Newton. Now, okay, now we can see that is how it goes. Let me get another question that can really help us. Now, when I have a load of 5 Newton gives an extension of 0.56 centimeter in a wire which obeys Hooke's law. What is the extension caused by a load of 20 Newton? What is the extension? What is we call caused by the load of that Newton? Now, solution to this problem. The first thing we know here is that we know what is called our applied force. This is our applied force, which is my applied force, applied load, which is force. It will be equals to 5 Newton. Now, applied load, which is 5 Newton. Now, our extension is 0.6, which is E 0. Now we are talking about 0.656 centimeter, which I'll convert it to what? To meter, which it will be okay. Now 0.6 that. Now, since I have it this way, my force constant, which is K, it will be equals to F all over E. What is my F? 5 Newton divided by, now this is centimeter. I have to convert it to what? Meter, which we all know 100 centimeter make 1 kilometer. We all know that. And 0.56 centimeter make what you don't know, which is meter, which I will be having x equals to 0.6 divided by 100, which is I'll be having 56. Okay, I'll be having that, which is to be 56 meter. I'll be having 56 meter. Now, 56 meter. Now, since I have it in that way, I can now continue by having, which is, I will divide this. Whatever I have, I will write it here. Now, since I have it, I will now move on by having my force, which is 20 Newton, and my constant force will be, after I divide this, which I will need my calculator at this point. Okay, now Now, with the help of my calculator, this will surely give me 0.09 0.09 Newton. Now, since I have it that way, it means I can continue by having my K, which is my K will be my K will be 0.09 Newton. Now, with that, I can now continue. Newton meter per meter. Newton per meter. Okay. Even though I use 0.6 without convert it, I can still have my answer, which is it will be in. Let me try to use that way, which is 0.56, which I'll be having when I press my calculator. I'll be having 8.93 Newton centimeter per centimeter, which I'll be having 8.93 Newton centimeter per centimeter. Now, since I have it that way, I can now say that what my E equals to what F all over K. Now, which is I have what is my force? My force is 20, which is my force is plus 20, which I have 20 Newton divided by what 8.93 that's Newton per. Now, which I will be adding calculator now 2.24 centimeter. 2.24 centimeter. That is all about that. This Newton cancel Newton on 2.24 centimeter. Now, can you see how it's being done now? And let me quickly add one or two questions to this before I round up this part. There's no time anymore. Now, I have this question also. On top of a spiral spring of force constant 500 Newton per centimeter is placed a mass of 5 multiplied by 10. Okay, if the string is compressed downward by the length of 0.02 meter and then released calculate the height of which mass is projected. That is what we are asked to find solution to this problem. Now, one thing we know there now is that we have to be talking about the work done in compressing the spring is equal to the potential energy is stored now in the spring. It means what I'm trying to do is that 1 over that, which it will be equals to what height, which is the potential of it. Now, which we all know that my force constant, which is K, is always equals to 500 Newton meter per meter, which is my E is 0.02 meter, which we have them on the question. Now I can answer my mass. It will be equals to 5 multiplied by 10 per. Now also my gravity, which is my G, it will be 10 meter per second squared. We all know that, which I cannot apply what I'm having here to generate my answer, which is 1 all over 2 multiplied by 500 multiplied by 0.02 squared equals to 5 multiplied by 10 10 squared, okay, 10 squared multiplied by 10 multiplied by h. By so doing that, I will have my h, which is my h will be equals to, this is squared and okay, now which I'll be having 0.1 divided by 0.05, which I'll be having 2 meter, which is my h. My height is 2 meter. Now my height is what? Is 2 meter. Now by so doing that, I think we should be okay on this part of elastic property of solid. Now, which is by applying Hooke's law. Don't forget that you are on with further solutions academy. Don't forget to subscribe, to share to your friend, to share, and also subscribe if you have not subscribed before. If you want to help us, you can reach us on this number 234-80344-95990. With this number, you can call us, you can WhatsApp us, and you can Telegram us also. Once again, thanks for watching.